We're going to talk about section 2.2, multiplicity. So if you haven't already, please make sure you watch the ed puzzle first. Otherwise, the first stuff is not going to make any sense. So again, watch on that so you can talk about the end behavior. So we'll kind of leave off. So as you already did that, using a leading term test to find the end behavior. So the main thing is we're looking for the leading term, which is we need to find the highest exponent, aka the degree. So this has the exponent of 1, of 2, of 3, of 0. This is what we're looking for. So this is going to be the thing that helps us determine what our graph's going to look like. Now, the fact that we learned if this is an odd, then we're going to have different directions for both the left side and the right side. If this is even, they're both going to go in the same direction. So if this is a degree highest exponent of 2 or 4 or 6, both arrows on both sides of your graph are either going to be pointing up or pointing down, depending on what your coefficient looks like. On this one, it's the opposite. Now, if you look at a normal like x cubed function that we've talked about before, that looks something like this. Something like this, and it ends like that. So that's what this is going to look like. And the reason why is because it's positive. If this was negative, we know that that's going to kind of flip the graph. So this end behavior off to the left is going to be pointing down, and then off to the right is going to be pointing up. If that was a degree of 5 and this leading coefficient was positive, same situation. Down here on example or B here, g of x. So the highest exponent, we're talking right here. So that's a negative in x to the 6. Now, if you think of an x squared, both of those would be pointing up. A negative leading coefficient means they point down. Same thing in this case. So what this is doing is these are both going to be pointing down, as we learned with that leading term test. Now, sometimes depending on the graph, like the higher the exponent, the more you're going to end up with possible more zeros, but there might be more turns in there. So for example, this thing might go like this and then go like that. Or it might go like this and have a bunch of terms and go like that. So it just kind of depends on the scenario and depends on all these other things, whether how many turning points and maximums you have and how many zeros you have. And what we'll talk about is whatever the degree is, that's how many at most zeros, aka x-intercepts or across the x-axis, that you're going to have. So here's what we're going to talk about with multiplicity. So it looks confusing, and it can be a little confusing here, but it says if you have this x minus c, so if it's in factored form, any exponent we call the multiplicity. So if you have it in factored form, most of the ones that we factor with quadratics are to a exponent of 1, which means the multiplicity is 1. And we typically don't do anything more associated with that. It's if it's bigger than 1 that we usually talk about it. So this says here, if the 0 is at c, remember if this is factored and I set x minus c equal to 0, that means your answer is going to be x equals c. So if I have x minus 2, then the 0 is going to be positive 2. If this is an x plus 4, then the 0 is going to be at negative 4 because you're kind of solving it. So it says if it has a odd multiplicity, that's really important, then the graph is going to cross at x equals. So the graph is going to cross the x-axis at x equals c, and sign's going to change. So what does that mean? That just means that if I had an x-axis, if it was coming down, it's going to hit right there and then go straight through. So the change of axis is, hey, it's a positive y value, and then after it's a negative y value. Or on the other side, in this case, it's crossing right here. So it's coming from a negative to a positive. So anything odd, so that means if it's a degree or a multiplicity of 1 or 3 or 7 or anything odd like that, it's going to hit the graph and go straight through, just like you normally have seen. Now, the difference is if it has an even multiplicity. So if it's to the second power or fourth power, then what it says is it's going to be tangent at that point. Now, what that means is it's going to hit and bounce back. So if that's right here, if it's coming from this, it's going to hit and then come back. It's going to bounce off the graph. Or if, let's say, if it was a different one, maybe it was underneath already, then if it's underneath, it's going to hit and then go back down. So that's what it means with even multiplicity. So whenever it's in factor form, look at the exponents. If you don't see an exponent, if you just see x minus 2, then technically speaking, that's to the first power, which is odd. So any odd multiplicity is going to go straight through the graph at those points. But if it's an even multiplicity, so if this exponent here is 2 or 4 or 6 or whatever, it would hit the graph and bounce back. Let's look at some examples. So it says state the number of possible real zeros and turning points. So the possible real zeros depends on your degree. The degree of this function is 4. So that means at most you're going to have 4 zeros or 4 x-intercepts. It's not saying you're going to have 4. It just means we're not going to have anything more than 4. So this is at most 4. This says how many turning points. Now, turning points are those maxes and mins, the local max, local mins. So if this is 4, whatever the degree is, you take that number and subtract 1 from it. From this case, that's 3. So we're going to have at most 3 turning points. So just a reminder that when it's saying that, that means that at most you're going to have 3 maxes or mins. It is not saying you're going to have exactly 3. It's saying you can't have more than 3. Just like this isn't saying, hey, a degree 4 is going to cross 4 times. That's not always going to be the case. It could, or it could be less than that. Then it says find the real zeros in sketch. So what I need to do is to find the actual real zeros. I need to set this equal to 0 and solve it. So 0 equals negative x to the 4th minus x to the 3rd plus 2x squared. And I'm going to factor. Now, all of these share an x, and the smallest exponent is an x squared. So I'm going to GCF out an x squared. However, I'm also going to take away a negative because that'll make my leading coefficient in my parentheses positive, which is much easier to factor. So I'm going to factor out this x squared. And as we've learned before, you're basically taking any of my original and dividing it by this. So a negative divided by a negative is positive. If I take an x to the 4th and divide it by an x to the 2nd, I'm really subtracting this. So 4 take away 2 is 2. So it's a positive and an x squared. This one, negative divided by a negative is a positive. X to the 3rd take away an x to the 2nd. 3 take away 2 is an x to the 1st, or just an x. Here, 2 divided by a negative, that's going to be a negative 2. And then I have 2 x's, and I'm taking away those 2 x's, which means I don't have anything left. At this point, now we're factoring out this. This is a quadratic trinomial that we started with. So basically what we're saying is we're looking for 2 numbers that are going to multiply to a negative 2 that are going to add up to a positive 1. So the only possibilities would be a negative 2 and a 1, or a 2 and a negative 1. Now the only way for those 2 numbers that are going to add up to a positive 1 are 2 and negative 1. So I'll have x plus 2, x minus 1. So this is my factored form. Now, I still have to solve these. This would give me a 0 at 0. If you notice, this exponent is 2, which means your multiplicity, this has a multiplicity of 2. And as we learned on the last slide, that means it's going to bounce off the graph at 0, as we'll talk about. This one, this is x equal negative 2. This multiplicity is going to be just 1. And that's because, technically speaking, it's not written here, there's a 1 there. Same thing here. You don't have to necessarily write that in, but just know that. This 0 would be at 1, and then it would be a multiplicity of 1 as well, which is odd. So how am I going to go ahead and graph this? Well, let's graph the points. So my first one here is at negative 2. So it's crossing right there. Another one at 0, and then my other one at 1. So I've got to do a couple of things to be able to help me. I know, though, since this multiplicity is even, that at this point it's going to bounce off the graph. If it's already above, it's going to bounce and come back up. If it's already below, it's going to bounce and come back down. The other thing I need to know is up here. Leading term test, just like we just reviewed. And you saw on the ed puzzle. This is even, which means both arrows are pointing up or they're pointing down. But my leading coefficient is negative. So that means both of my arrows are going to point down. So these arrows are coming from this. So the only way I can draw this graph is this. At the x equal negative 2 right here, that was a multiplicity of 1. So anything has to go through. So this graph has to come through this point. Now it comes to this 0 at 0. We said the multiplicity was 0, which means it's going to bounce off the graph. So it has to hit and then come back up. And then this one at 1 is a multiplicity of 1, which means it has to go through. So it's got to go through, and then we know it's going to go down the rest of the way because that's what the leading term test told us. That's the only way that you can graph those. Since this was a multiplicity of 1, that was a multiplicity of 1, so they went straight through the graph. This one came from above and kept on going up. This one came from the top and kept on going down. This multiplicity was even. That was a 2, so it bounced off the graph. So get another one. State the number of possible real zeros. So same thing on here. There are at most, in this case, degree is 4. There's at most 4 real zeros. 4 minus 1 is 3. There are at most 3 turning points. And again, turning points, we're talking about maxes and mins. So it says, then find the real zeros in sketch. So we'll do that. So I'm going to set this whole c of x equal to 0, 3x to the fourth, and I'm going to do the same thing. I'm going to kind of GCF out what I have. So if I look to see what's in common, 3 and 4, the only thing that they share is a 1, but they do share an x in the smallest exponents and x to the third. So I'm going to GCF out an x to the third. So 3 divided by 1 is 3. And then 4 take away 3 is an x to the first, or just an x. Negative 4 divided by 1 is a negative 4. And then I have 3, but I'm taking away 3, which means it doesn't have anymore. Now this is as factored as I can go. This has a 0 at x equals 0. This has a 0 at 4/3. And the reason that that's at a 4/3 is if I set 3x minus 4 equal to 0, you'd add 4 first and then divide by 3. So that's where that's coming from. Now the multiplicities, those are your exponents. This exponent is a 3, which is an odd. So this has a multiplicity of 3. This is technically to the first, so that multiplicity of 1. Both of those, in this case, are odd, which means they're just going to hit the graph and keep on going. So it's either going to come up and hit the graph and keep going, or it's going to come down and hit the graph and keep going. So I've got a couple of zeros. There's 1 at 0, so I'll put that there. And then I have 1 at 4/3, which is like 1.3 repeating. So leading term test. Degree is even. That means either both arrows are pointing up or pointing down. This is positive. So in this scenario, they both have to be facing up. So I have to draw this and kind of sketch it out. And again, Desmos can help us a little bit, but this is showing our work to get to that point. So what it could look like is it could look like something like this, where it almost looks like a U-shaped curve. Another thing that it could kind of look like too, depending on what's going on, is I'll still have those same zeros, but there might be more things going on with it. So if I had 1 here and there, this thing, what it could look like, it could be going this and then kind of going up and then down. So there could be some more changes going on in there. And the only really way to know that is if you're plugging in points or using Desmos to help you out.